All right, so now what we're going to look at is using our knowledge of solving trig equations in radians. Again, that's the key here is that you have to have your calculator in radians. So it should say RAD, R on the top, just like when you have it in degree mode. Well, now we're in radian mode. All right, and so we'll start off here. Solve the equation 5 sine theta plus 1 equals 0 on the interval of 0 to 2 pi. So in other words, in 360 degrees. All right, so the first thing I'm going to do here is I'm going to, well, I need a better symbol than theta. So I'm going to use hashtag for theta because I don't have it on my computer here. So first of all, I'm going to isolate sine theta. So I've got 5 sine theta. Actually, there we go. There's our theta. Equals, I'm going to move that -1 to the other side. All right, so then I'm going to, first of all, then divide both sides by 5 to get sine theta by itself. All right, and so what I end up with here is sine theta is equal to, let me see, I take -1 divided by 5, I get negative 0.2. All right, now, here's what we're looking at is we've got 2 answers we're going to get. All right, 2 answers. So I'm going to draw how we're going to find these answers first off. So we're going to get 2 of them. So here's the first one we're going to look at. Here's the second. Now, again, when we're dealing with the cast rule, which we are going to have to deal with. So again, there's 2 things going on at the same time. So I get CAST on both triangles here. Okay. Now, first of all, I'm going to find my angle here in radian measure. But what I'm going to do, and this always messes people up here, is I don't care about the minus sign. The cast rule is going to take care of the sign of our trig ratio. But I'm going to find sine inverse. How am I going to draw that here? -1 of just 0.2. Again, I do not care about the sign. The cast rule takes care of that. And when I do the sine inverse of 0.2 in radian measure, I get, no way, okay. I get 0.2. That doesn't always happen. We'll see that. Okay, so that is my angle in radian measure. Now, where does that look on our 2 answers? And why do I say there's 2 answers? Because in this case, our sine ratio is negative. So that's telling me that my angle cannot be here in this quadrant and it cannot be in this quadrant because all ratios are positive in the first quadrant and the sine ratio is positive in the second. So it's gone. Can't be in the 1 and 2 quadrant. But here's where our ratio can be located. It can be located in our 3rd quadrant, and it can be located in our 4th quadrant. Now, what this angle here of 0.2 is saying is that is my reference angle, 0.2. And it's right here, 0.2, because again, your reference angle is always measured with the x-axis. And so now I can actually find my solutions. Because my first answer here in number 1 is going to be theta equals, all right, we have pi would be all the way around plus the 0.2. And so our actual angle, because this 0.2 is just our reference angle here, is pi, which is 3.14, plus 0.2, which will give me in radian measure 3.34. That is one answer. The other answer here is that all the way around is 2 pi, but we come up 0.2 short. So my other angle is going to be 2 pi, which is all the way around, minus 0.2 because we didn't quite get all the way around. And so our other angle that we're talking about that solves this equation is 2 pi, which is, again, 2 times 3.14, which is 6.28, minus 0.2. And so our other angle in radian measure is 6.08. There we go. So there's our two answers that will solve this trigonometric equation, linear trigonometric equation. All right, let's again try a couple more here. Solve the equation 3 sine 4 theta plus 2 equals 0. All right, this one's a little messed up because, first of all, I don't just have a theta, I have a 4 theta. So I'm going to simplify things here. And I'm going to let x, and it's not the last time we're going to do this today, I'm going to let x equal 4 theta. So that way my equation now, I'm just dealing with an x. So my equation now is 3 times sine x plus 2 equals 0. And just like I did in the last example, now I'm going to get this sine ratio by itself. All right, so I'm going to have 3 sine x equals -2. Then I'm going to divide both sides by 3. And so now we're going to get to the same part we were at before. Sine x is equal to -2 over 3, which is negative 0.67. All right. So now we're going to have two answers. Once again. So there's my first answer where I'm going to figure it out. My second answer, I'll figure it out over here. Again, I have my cast rule. C-A-S-T. That tells me where these trig ratios are positive or negative. C-A-S-T. All right. Now, again, what I'm going to do is first is I need my reference angle. That's what all I'm finding here. So I don't care about this minus sign. I'm going to go sine -1 of 0.67. Because, again, this minus sign, that's the whole sign thing is for the cast rule. And when I do that, I get 0.73. So 0.73 is my reference angle. All right. Now, where are we going to be looking for this reference angle to help us out? The cast rule. We have sine ratio is negative. So that can't happen here or here. Oh, that's the same as last time. Same thing here. So our terminal arm, our possible answers, have to be in the third quadrant or the fourth quadrant. And our reference angle here is 0.73 and 0.73. All right, so now I know this is that x, that's what I'm solving right now. X is equal to, we have pi, because that's all the way around here, plus 0.73, because pi, again, is 180 degrees. So to get through the first two quadrants, that's pi plus that 0.73. And x values end up being, let me see here, 3.87. All right, now again, the other x value, 2 pi is all the way around. So 2 pi minus 0.73. And x is going to equal, let's see here, 2 pi is 6.28 minus 0.73 is 5.55. Okay, so we solve for x. That solves this equation right here. We're trying to solve this equation up here. So, but x is equal to 4 theta. So 4 theta is equal to 3.87. Well, I'm going to divide both sides by 4 here. And I get my actual theta answer to be 0.97. And same thing with our second answer, x equals 5.55. Well, x is 4 theta equals 5.55. Once again, I'm going to divide both sides by 4 to get my theta by itself, and I'm going to get 1 point, let me see here, 1.39. There we go. So that time we made a substitution because I had something crazy inside my trigonomic function. So that's one way to deal with this. Just make a substitution and then resubstitute it back after. All right, let's try another one here. Again, take some time to get used to this stuff. There's no doubt about that. Okay, so example 3. Solve the equation 4 times secant theta plus 2 equals 1 on the interval, again, 0 to 2 pi, 0 to 360 degrees. All right, so the first thing, again, I'm going to do is simplify this equation. All right, so I'm going to multiply the rainbow rule there. So I'm going to have 4 times secant theta plus 4 times 2, which is 8, equals 1. All right. I'm going to move that 8 over to the other side, so it's going to become negative 8. And so 1 minus 8 would be a minus 7. All right, I'm going to divide both sides by 4. And so I get secant theta here equals negative 7 over 4. But again, secant is the reciprocal of cos. So I can flip it. So actually I can solve this ratio. Cos theta is equal to negative 4 over 7. There we go. So because, again, the reciprocal of secant is cos, flip the fraction, change it to cos theta. Now, I'm going to have 2 answers. Here's my first answer. Here's my second answer over here. Again, we're going to have to use the cast rule. There it is. All right, so now I need to know what my reference angle is in radians. So I'm going to use cos inverse of what's negative? Hold on here. I better figure out negative 4 over 7 is negative. I gotta type this in my calculator. 0.57. All right, so I'm going to do the cos inverse here of, can I get in there? There we go. Of 0.57. Again, I do not care about the negative sign. That will take care of itself with the cast rule. But if I take the cos inverse of 0.57, I get 0.96. All right, so that 0.96 is my reference angle in radians. So now to apply the cast rule, I have a negative cosine. So negative, it can't be in the first quadrant because all ratios are positive. And then cosine is also positive in the fourth quadrant. So it can't be that because our cosine is negative. And so our 2 answers, we're going to have 1 in the second quadrant and 1 in the third quadrant. Again, our reference angle is 0.96. It is always measured with the x-axis. There we go. All right, so now when I'm finding my theta, in my first answer here, again, 180 degrees is pi, but we don't go 180 degrees on this first one. So I'm going to have pi minus that 0.96. And so my theta, apologize for the symbols here. So I take 3.14 and I subtract 0.96. And I end up with 2.18. There's my one answer for theta. The other one here is in the third quadrant where theta is equal to, we got pi, which is 180 degrees, and then we go past it, 0.96. So this time my angle is equal to 3.14 plus 0.96, which is 4.1. And there is my 2 angles, again, in radians, 2.18 and 4.1. All right, let's try something a little different here. The high tide in Matthews Cove, New Brunswick, is at midnight. The water level at high tide is 7.5 meters. The depth d of meters of the water of the cove in time t hours is modeled by the equation right there. Jenny is planning a day trip to the cove tomorrow, but the water needs to be at least 2 meters deep for her to maneuver her boat safely. At what times will it be safe for her to sail to Matthews Cove? Now, we have not done a lot of graphing. We've done no graphing with trig. So this question I'm going to change because we don't have the ability to solve this particular question. And I'm going to change this question to find when the water level is at a height of 2 meters. That's what I'm changing the question to because we haven't looked at intervals for trig functions. We won't have time to do that. All right, so, but we are going to be able to find when the water level is at a height of 2 meters, which is a nice way of saying find t when d equals 2. All right, so here's my equation, and I'm going to substitute 2 in for d. And so that my equation is going to be 2 is equal to 3.5 times cos of this big mess, cos pi t divided by 6, yikes, plus 4. All right, so here's what I'm going to do is I'm going to because again, we have a big mess here. So I'm going to make a substitution to completely simplify this. So I'm going to let's go with theta equal this pi t divided by 6. All right, so that's going to simplify my equation quite a bit for me because I don't want to solve for that whole mess. I want to simplify things. So I got 2 is equal to 3.5 times cos of theta now, plus 4. All right, so now I'm going to, again, get this cos ratio by itself. So I'm going to bring the 4 over to the other side. Of course, it'll become negative 4. So 2 minus 4 is negative 2. Is equal to 3.5 times cos theta. All right. Then I'm going to divide here both sides by 3.5. All right, and so what I end up with here is that cos theta is equal to negative 2 divided by 3.5, which is 0.57. So I get negative 0.57. All right, so from that, I'm going to get my 2 answers. Whoops. All right, so we're at 1 answer here. And 1 answer over here. Again, we're going to have to apply the cast rule. C-A-S-T, C-A-S-T. All right. Now, again, I do not care about the sign. The sign will be taken. Well, I do care about the sign, but it will be taken care of with the cast rule. What I want is my angle, my reference angle here in radians. So I'm going to take cos inverse of 0.57. And I end up getting, let's see here, in radians, 0.96. I have that last one. Oh, I did. Oh, man. Change it up, man. All right. So, again, with the cast rule, cosine's negative. So, it can't be here. And C, so it can't be here. Same over here. It can't be here. And can't be here. All right. So, now when I look at my reference angle, I got 1 answer here and 1 answer right here. So that 0.96, again, your reference angle is always in reference to your x-axis or measured towards your x-axis. So there we go. So there's our 2.96s. So now in the first one here, I'm figuring out theta is going to equal pi. So my 3.14 subtract 0.96. And that means my theta is going to equal, let's see here, 2.18. All right. Over on my second answer, theta, we have 3.14. My pi, which again is 180 degrees, but this time add an extra 0.96. And so I end up with, let's see here, add those together and I get 4.1. All right, now that's theta. But we're trying to find the time. How much time has gone by? So theta is equal to pi t divided by 6. So that means, so here, extend my page here. Theta here is, again, pi t, because we're solving for t, the time, equals 2.18. All right, so the first thing I'm going to do is multiply both sides by 6. So then I got pi t here equals 6 times 2.18. We get 13.08. And then divide both sides by pi. And I get 4.17. So that's 4.17 hours after midnight, because I believe that's when the high tide comes in here. Let's see here. Yes, at midnight. High tide's at midnight. So it's at a water level of 4.17 hours after midnight. We'll be at 2 meters. All right, so that's probably around 4 something in the morning. 4.4 and a bit, yeah, 4:10 or 4:12 in the morning. All right, now the other time where the water level's at 2 meters, again, I'm going to use my substitution here where theta is pi t divided by 6 is equal to 4.1. So again, I'm going to multiply both sides by 6. So then I get pi t is equal to, let's see here, 4.1 times 6 is 24.6. All right, then divide both sides by pi. And I get 7.83 hours after midnight, which is probably like, I don't know, 7:50 a.m., somewhere in there. You got 80% of an hour, or 0.83 of an hour. Oh, I actually figured out 0.83 times 60 minutes. Yeah, it's 749.8. So there we go. So those are the 2 times that our water level would be at 2 meters high. But again, this is a case where we had just not a theta inside our trig ratio. And so I made a substitution and then resubstituted at the end when I've actually found theta to solve for our t value. Now, if we were in a bricks and mortar school and we